Okay, so there's the priority queue interface. Let's make a class that implements priority queue interface. We'll call this, I guess we can use priority queue, can't we? No, I can't. Sure, that'll do. We'll write our priority queue implementation, and we say this one has to implement priority queue, the interface. Oh, that's what I did. I used the name without interface. So priority queue by itself is the interface, and the implementation is going to look like that. And let's just see what it dislikes. It says we haven't written those methods. So there's all the methods that we need to write. And we still get an error message. Basically says you haven't done the E thing right. Okay. This is another weird Java-ism. Yeah, we did the weird thing right. Implements, let's see if I can get this right. We'll give that a try. One more time.
Is that an extra angle bracket?
That one needs to go right there. Oops, wrong one.
Oh, okay.
Just fiddling with it to try to get it to look right. Priority queue for E-type things. There we go. This is it's just a weird Java-ism, and it only took me like 8 hours worth of digging to find it at one point, but that's just what it has to be. Okay, and so basically what it says is it still says what we want. We're going to do a priority queue thing, and whatever E objects we have to do the same thing that the other one did, which is they have to have comparable, and this object and thing for some reason you can't leave out. Just let me put it back in. I'll show you. If we try to get rid of it, I don't think it'll be too happy. Yeah, well, we'll run with it for a while. I think it's going to break when we do it at runtime, but that's okay. We'll put it back in then. Okay, so there's our start of our priority queue class. What kind of information do we need to store? What's the storage facility going to be? It's, well, we don't want to use array list. We'll go right back down to the nitty-gritty. We'll use an array itself. So that's going to be private E array of whatever it happens to be, all items. And we should write the constructor And what we'll do is we'll just make this some size. We can always make it grow later. This is the one where you want to say a new E array of size, whatever it happens to be. 64, hopefully some power of 2. And it says, no, you can't do that. So this is the one where we have to say, I want to make a new object array of the correct size, and then cast it to an E array to make it somewhat happy. Okay. So what happens if someone says add? Put it at the bottom. So all items sub what ends up getting the new item. And notice there's no nodes here, so we can add it in directly. What are we going to put in for a subscript? Need to keep a counter of what thing we're interested in. The bottom one, which is what's interesting about it. Not only is it the bottom one, but it's empty. So we're back to what we did for arrays way back when. We're still managing this thing like an array where we've got next empty slot is the one that we're trying to put something in. So we're going to need another variable, our standard next empty slot, and next empty slot needs to start out starts out at the 0 position, and then we put the item into the next empty slot. And then what happens? Next empty slot has to go up. Sure, we can do that. And now what? Now, in general, we've got the problem of we've been added at the very bottom, and we want to fight our way up to the top as high as we can go. Okay. So, in English, that would be, just thinking of a phrase for what we're going to attempt to do so we have it clear in our minds. Well, it's not just what's the process or if we were to say to somebody over the phone what we're attempting to do here, if you start out at the bottom, just some words to use. Work your way up. Sure. So we want to work our way up until we hit the correct spot. Okay? And work your way up, in order to do that, is going to need to know where we are now. So where we are now is next empty slot -1, since we bumped up next empty slot when we filled it. Okay? So notice I resisted the temptation to even start thinking about, oh, okay, I have to do this and comparing and that. I just came up with the general idea. I need to somehow get to the top of the pile. Right? So if you want, now you can write private void work your way up. Int, and this is current position. Now we can figure out how to do it. So how do you work your way up to the top of the pile? Or do the general idea or the specifics? Okay, so what's the general idea? Where do you want to end up? Be the biggest bully. Get to the top. So for as long as I'm not at the top of the pile, how do you know you're at the top of the pile? So while current position is not equal to 0, we're just going to keep trying. So there's the aggressive thing. I'm at the bottom, and I know I'm going to end up at the top of the pile, so I'm just going to go screaming right up there as fast as I can go, beating people up along the way. Okay? So now you need to challenge somebody. So what do you need to do to challenge? You need to find somebody to challenge, so the big question is, where are they? So we need the position of the person just above us. Tree terminology, that would be the parent. So what we need is parent position is what? Divide by 2 minus 1, maybe. My suggestion here is resist the temptation to do the calculation at all right there and put it into a method. Okay, so I'm just going to write get parent position for the current position. So I'm trying to abstract it and go, well, I don't care what the calculation is. I'm telling you, all I want is just tell me where the parent is in the array. That's all I need to know. So let's write get parent position. So there's get parent position, and now you can put the calculation in here if you want, which somebody said it's current position, what'd you say? Divide by 2 minus 1 afterwards, so we'll just fully bracket all our expressions, and we'll hope for the best with that. So now everybody in their heads is going, well, does it work or doesn't it? What's the best way to decide does or doesn't it work? Unit test. So there's one of the joys of if we do the calculation here, you can't test it. But if you take the calculation and drop it even into a simple method, we're going to be able to write some unit test. Here's a number, here's the number coming in, here's what we expect it to be. Okay? And so we can wipe out all of the uncertainty by going and doing a unit test on what seems like a completely trivial math calculation that none of us can figure out in our heads. Okay? So now's a good time to say, let's do a unit test. So we'll make a unit test, we'll do a setup in case we need it. And we'll say, okay, to add it to the build path. And we want to test get parent position. So we'll write a test. I think that, oh, we need a queue object. Sure. So we'll make our queue object. We need to put in the type of thing that we want. I said we're going to use patient. And so now that we've got a queue to talk to, we can say, I think that queue dot get parent position on, pick a number, 8 should be what? Should be 3. So there's the joy of, if you take it off the diagram, the assert statement is pretty obvious, and now you can worry about whether or not the number's right. Except, get parent position doesn't exist. Let me just try, oops, capitalizing it. And still doesn't like it because if you go back and look at our implementation, we've marked it as private. Okay, so here's a problem with putting private on these things that, I mean, it's private because we don't want people to see it, but the fact that you mark it as private now means that unit tests can't see it, and this is a perfect little example of why not have it so that unit tests can see it. You want to be able to test this function. Oops. So, unfortunately, anything that you mark as private, JUnit can't see on purpose. Not so good. You could try protected, but even that won't work because then protected only works for classes that extend the current one, and we're not extending the current one. Nah.
Temporarily mark it as public?
You could. One of the ways that you could do it is you could just quietly mark it as public. And hope you remember to change it back, which, again, you're sort of breaking the rules, right? And now you have to remember to do something that you're unlikely to remember to do, and now if you continue to do that to test things that are internal, eventually you're allowing people to see things that they shouldn't be looking at all, like nodes and whatever else. So it's sort of bad news. Okay? And this is a real head scratcher because it's traditional that you can't do this. Okay? And if you go and look on Stack Overflow, they've got all sorts of weird answers about how to do it and why you should or shouldn't, and it means that you're not using your API correctly and all of that sort of silliness. But in fact, it's a reasonable thing to want to test. So, how do we work around it? Well, here's the easy solution. So far, we've had this thing called a package, and we haven't really used it, but the idea of a package in Java is more or less to provide a library of stuff, okay? And so what we're writing here is something that is more of a library function that's meant to be used by others and not stand on its own, and so we should give the library a name and plop all the stuff into a library. And so what I'm going to do here is inside this source file, I'm going to make a new package. Again, think library of stuff. And we'll just call it, can be called heap, even though the project is called heap, doesn't really matter. They're two different things. So now I've got this package called heap, and what I'm going to do is I'm just going to take all of this stuff and I'm going to slide it into there. Maybe a little more slowly since I'm recording, or maybe one by one would be fine. Just going to take all of them and dump them into there so that they're no longer in the default package. And so now you'll notice at the top of the file what it's done is it says, okay, that's a package called heap, so think a library of heap stuff. And then what I can do is I can change this thing. Instead of saying public, I'm not going to say anything at all, which is maybe a little better than saying public, which implies everybody can get at it, but not as good as saying private, which is what I really mean. Okay? So the rule in Java, which we haven't used so far, is that if you don't put anything on there in front of variables or in front of methods, then the default is what they call package private, which means people who are in this heap package can make use of those things, but if you're outside of the heap package, you can't. Okay? And to me, it's a little bit backwards in the design, because I would prefer to say private specifically, because it means private, and then I would prefer to have another keyword that says, oh, but people in the package can see it. So work from most restrictive to least restrictive, and this is actually sort of a combination. It's the guys who designed it obviously thought that these packages were important, and so we'll let people look at stuff within packages if you don't say anything, because packages should be friendly, know what's going on internally. But once you're outside of the package, then private and public make more sense. Okay? So the long and short of it is that's the easiest way to do unit testing of these things, and you just have to get used to the idea that this thing here is actually package private. It can't be seen outside of the heap project. Okay, so regular mortals can't look at it, but it allows our unit tests to now work. Okay? So we can give the unit test a try. And no, actually what you get is not that thing failed, but you get this class cast exception. And I'll just see if I can show you what it says for that. It says something really weird here. It says object can't be cast to comparable. And that's where this weirdness comes in of way back when, where I said what we're going to have to do is we're going to have to go on this implementation thing here, and we're going to have to stuff on the words here. Oh, this thing is actually an object, and the ampersand means and there, and it also does comparable. Another bit of Java weirdness that takes forever to figure out. But now when we run the unit tests, we end up with the thing passing. So parent position of 8 does happen to be 3. What else have we got? 7 should also be 3. So 7 should also be 3. Try that one. Diagram's right. I guess the result is wrong. While we're at it, let's just add in another couple more. So if we did 5 and 6, they should have 2. Okay, so picked them off the diagram, they got to be right. I guess that means that we're wrong in our formula. Anybody want to try a different formula?
If current position mod 2 is exactly equal to 0, return.
It doesn't need an if statement. It's actually just there's just a calculation for it. Believe it or not, no if statement required. Come on, you math people. Sort of, kind of, almost right. Subtract 1. Oops. Subtract 1 and then do the division. Okay. So 8 and 7 become 6, basically, and then you divide by 2 and you get 3. Okay, so we'll just give those a try and run it, and now it succeeds. Okay, so just a quick wrap up for today. One of the reasons why I'm doing this is knowledge you learn about heap, but I want to go back to sort of, this is the summary, this is like the masterclass thing of when you're writing code, here's a good way to write code to see whether or not you can get it to work. And notice that if we just would have put the formula in on that one line way back when, we would have ended up in a heap of trouble. I just had to say it. Because we would have spent all our time going, oh, I'll put a, you put a number in, you think you got it right, you don't bother to check it, you go and you write a whole bunch more code that's based on that thing working, and all of a sudden the extra code that you've written is pretty much guaranteed to be probably buggy, right? Might work sometimes, but not all times, because it did work for one assert statement you put in, but if we tried another case, it was wrong. Right? So all of a sudden you spend all your time farther down on a useless thing because you didn't do the right thing at the beginning. And so the right thing at the beginning is always to try to put code into a method, even for something that's totally simple, a one-liner in math, right? Do some samples off of a diagram known to be correct, put that into unit tests. When it's known to be correct, you're ready to move on. Okay? One step at a time. Okay? So we get parent position, so now we'll figure out what to do with it afterwards for work your way up. And we'll see you tomorrow, and we should be able to finish this one off.